So hello everyone, welcome to another video on object-oriented programming with C++. In this video we are going to look at something that we have already talked about a lot in our previous videos. Those are constructor, and then we are going to look at something new, that is destructor. So we are going to look at constructor and destructor in details in this video. This is going to be a programming video like our last video. So without further ado, let us begin this video. So I'm going to write a few programs, and I'm going to start by including, as always, I'm going to include IOStream, and then using namespace std. Alright, so the first thing that I'm going to do is I'm going to create a class. Let me call it parent class, because eventually we are going to look at inheritance. So this parent class, I'm going to keep it very simple. I'm going to have one method, and that is going to be a constructor. Now you already know this, that the constructor of a class should have the name similar to that of the class, right? So if we have this class called parent class, then our constructor should be called parent class. Okay, now we have that. Inside this method, I am simply going to print out constructor of parent class. Okay, and I'm going to print a new line, and that would be all. Okay, now in my main program, main function, I'm going to create an object of the parent class. Let me call it P, and that would be all. I'm going to return from main. Okay, so this is the program that I have created. Let me go ahead and compile and run this program. Okay, I see that the method has been called. This method that I have created is called, and because the method is called, I can see this output constructor of parent class being printed to my standard output. Okay, now let us talk a little bit of what is happening behind the scene. In line number 10, I am creating an object of parent class. When I am creating this object, when an object is created, this constructor is called, right? The constructor is the first thing that is called when creating an object. Now, what is the reason why we would have a constructor? Say in your program, you are creating an array. Okay, in your class, you need an array. So this array, you have decided that you are going to create this array in the heap memory. So you are dynamically going to allocate memory for the array in the heap. Now to do this, you would have to run some code. So all this kind of initialization, say initializing this array, all this thing that you need to do at the very beginning before using your object are supposed to be done inside the constructor. So that is the that is one of the reason why you would have a constructor. Now depending on your application logic, you may have other uses of constructor, but then the go-to reason why constructor might be used is there are a few things that needs to be done at the very beginning for the object when we are creating an object, right? So this is those kind of things we are going to do in the constructor. Now you also know that constructor can be overloaded. That means I can have multiple constructor. I can have a constructor, for example, I am creating another constructor that takes one parameter, one integer parameter. Okay, and this is going to print constructor of parent class called with I is the parameter that I am going to send, and then I print a new line. Let me create another constructor, and this is going to take two parameters, I and j. Alright, let's go ahead and print the same thing almost. Let me copy from here, and I'm pasting over here, and I'm going to print and j. Alright, so this is my constructor that takes two parameter. This is overloading. I have the same class name, method name, but with different parameters. So depending on what are the parameters that are sent, different methods will be called, right? So let me create another one over here. Here, instead of sending integer, I am sending once again two parameters, but instead of sending integer, I am sending floats. Okay, and to differentiate between these two, I am going to print a constructor of parent class called with float ing. Okay, now let me go ahead and compile and run this program. So I'm compiling and I'm about to run. Yes, I am not passing any parameter when I'm creating this object. Therefore, this constructor that does not accept any parameter is being called. Let me go ahead and run this with one parameter. This is going to be an integer 5, and I'm going to compile and run this, and then I'm going to see that this other constructor that I have created that takes one integer as a parameter, that is being called. Okay, constructor of parent class with 5. Now let me do something. Let me call this with 5.5. This is a floating point number. Okay, so let me go ahead and run this. Okay, it's compiling and it is running. Now what has happened is that this float that I have passed, this double that I have passed, is casted, is implicitly internally casted, internally changed into an integer, and then the integer is passed into this constructor. Once again, this constructor is called that takes one parameter. Alright, so I am passing a integer. This constructor is supposed to receive a integer. I am passing a float or a double, but then this double is converted into an integer before being passed to the constructor. So this 5.5 becomes 5, and this constructor is called with 5, and the constructor executes, right? Therefore I am this is printed constructor of parent class called with 5. Fine. Now let me do one thing. Let me call with 5 and 6. Now I am passing two integers as parameter. What is going to happen? Let us go ahead and compile this. Okay, constructor of parent class is called with 5 and 6. This is good. Okay, now I am passing two integers 5 and 6, and then this constructor that accepts two integers as parameter is being called. Okay, now let me do something that might be problematic. So I am passing 5.5 and 6.5. Okay, let me go ahead and compile. Okay, now I have an error. Now I was expecting this error. Why is this error? These are doubles that I am sending. Okay, but here I am going to receive an int, here I am going to receive a float. Now say I do not have this second method, then what is going to happen? Now everything is going to run properly, right? This 5.5 and 6.5, these doubles are going to be casted, internally going to be converted into integer, and integers are going to be passed to this function, to this method. So parent class constructor that accepts two integers is going to be called with two integers 5 and 6. This 5.5 and 6.5 are going to be converted into 5 and 6, and this method is going to be called, and that is being called. I see the output constructor of parent class with 5 and 6 being called. So everything is going fine. But now when I have this other method, this one more constructor, there is ambiguity in what is the casting that should happen. Should this be casted into an integer, or should this be casted into a float? Okay, I am going to remove that ambiguity. I am going to remove that ambiguity by explicitly mentioning that my x, which had this value 5.5, and y, I am going to create two variables x and y with 6.5. Okay, now x and y are float, so there is no ambiguity in that, and I'm, instead of passing these values directly, these hard-coded numbers that I wrote in line number 25.5 and 6.5, instead of writing that, I'm going to pass this x and y as parameter. Okay, so let me go ahead and compile this, and yeah, now I am calling this constructor of parent class with float, this constructor with values 5.5 and 6.5. So that is being printed. Okay, so fine, all these are fine. Okay, the thing that I want to show you at this point of time, the thing that you should understand is this. What is a constructor? A constructor is a method that has the same name as the name of the class. When is a constructor called? When we create an object out of the class. At that point, the constructor is going to be called. Okay. Now, constructor can be overloaded. We can see that. Constructor do not have a return value. Okay. Be very sure of that. Constructor does not have a return value. I am not writing any void or int or anything in front of the name of the constructor. So, don't confuse that. Alright. Now, let us go back and have one constructor. So, that would do. Let me remove all this other constructor and let me look at destructor. So, destructor like constructor would have the name same as the name of the class. So, my name of the class is parent class. Destructor is going to have the name parent class. But there is one minor difference between constructor and destructor. In front of destructor, I am going to write this tilde. Alright. And then let me write this some thing that I should do in destructor. So destructor is going to print destructor of parent class. Okay, and I'm going to print a new line. Now let me go ahead and execute this program. Okay, so the constructor was called when I created this object, and at some point of time the destructor was called. Now when is the destructor being called? So that is the question. Okay, now destructor is called when the object goes out of scope. Okay, when the object was allocated some memory, when the object is deleted from memory, at that time destructor is called. Now we are not explicitly deleting this object P, the object that we had created, this parent class object. We had created this parent class object, but we are not explicitly deleting it. Then what is happening? This is happening. Main is a function, right? So we had created this object P inside main. So P, this object P is a local variable of main. Now this object P is going to be allocated memory in stack. So once we have done executing, then what is going to happen is this memory that was allocated for main is going to be deallocated automatically, right? So once main is done executing, once I reach this statement that return, I have to return from main. Okay, at that point of time, all this memory that was allocated for main is going to be deallocated. So when this deallocation of memory happens, when this object, when this P object that we had created in the stack, in the memory that was available for main, when this P object is removed from memory, when this memory that was allocated for main is removed from stack, okay, at that point of time the destructor is going to be called. Fine. Okay, so destructor is called when deallocating from memory. Okay, like constructor, destructor does not have a return type. Let us see if destructor, at least this destructor we can see is not taking any parameter. Okay, now let us try to have a destructor that takes a parameter. Let me go ahead and compile. Okay, I see an error. Destructor may not have parameters. Okay, so that is another point that you have to remember. Destructor cannot have parameter. Okay, that means this is the only signature of destructor that is possible for our class. Okay, that means we can have a destructor. Destructor will have a name. The name will be same as the name of the class, and there will be a tilde in front of the name of the destructor, and that the destructor is not going to take any parameter. So there is going to be only one signature for destructor, and that means one more thing. That implies one more thing. Destructor cannot be overloaded. Let us try to overload destructor. Let us see what is going to happen. I am going to create another destructor, and here I am going to take a parameter, okay, and I'm going to write not possible. Okay, let me go ahead and try to compile this, and no, I have an error. This is not possible. So the takeaway here is this: I can have more than one constructor in a class, but there can be only one destructor. Alright, now what is the task for a destructor? It is the opposite of what we did in constructor. Obviously, in constructor we were supposed to allocate memory, right? We were supposed to initialize our variables, say if we wanted something to do something in heap. Now in destructor, once we are done working with our object, okay, destructor is going to be called when we remove this object from memory. So all these other things that you had allocated in heap has to be deallocated in destructor. Okay, so whatever resources you are using, that you had started using in constructor, you are supposed to deallocate those resources. You have to explicitly stop using those resources in destructor. Alright, fine. Now there is one more thing that I want to do. Now destructor, at this point I am seeing, let me go ahead and compile this to give everything, to give the output ready. So I have seen when I create an object, this constructor is called, and when I am done when I return from main, the destructor is called. Okay, let me show this to you explicitly using a function. I am going to create a function. I am calling it fun, and inside this function I am going to create an object of parent class. I am calling it p again. Okay, and this is something that I am going to do. Here I am going to print before fun and a new line. Then I am going to call the fun function, and then I am going to print after fun. Okay, so like main, fun is also a function, and I'm going to call this function. So let us see what would be the output, and then we will discuss the output. Okay, so this is what is happening. First, obviously my main function is going to start executing. So line number 16 is the first line that executes. Here I am printing before fun. So before fun is being printed. Then what do? I am calling this fun function. So I reach the fun function, and then I execute line number 13. In line number 13, I am creating an object. Okay, this is a local object inside this fun function, and this will be allocated memory in stack. Okay, so memory for this object will be allocated in stack. So I allocate memory for this object in stack. I use this object in my fun function. I do something with it, and then I return from this fun function. Okay, now at this point when I return from this fun function, this destructor is going to be called, right? So I return from the fun function, the destructor is called, and then I reach line number 18, in which I print after fun. Alright, and then I return from main. Okay, there is nothing that I created in main, so there is nothing been destroyed in main. So let me go ahead and create one more object inside main. So I'm going to call it C. Okay, fine. Let's go ahead and compile this, and this is what I see. In line number 16, when I create this C object, this constructor is called. Alright, then in line number 17, this before fun is being printed. Then in line number 18, I am calling the fun function. I go to fun function. There I am creating another object P. So the constructor for P is being called. Alright, after that I return from fun. At that point the destructor for fun is called. Okay, I return from fun, and I am back in line number 17. In line number 17, I run this after fun. So after fun is being printed into my console, and then I return from main. At this point, when I return from main, this destructor of this object that I had created, this C object that I had created in main, is being called. Okay, everything is good, right? Now let us go ahead and do something else. Let me not have this object inside main that I had created, this C object, and what I'm going to do is I'm going to create this P object. Okay, this object that I had created, I'm going to create this in heap. Okay, previously I was creating this in stack. Okay, it was a local variable inside my fun function. Now I am going to create it in heap, right? So using this new keyword, we know this already, how to create how to allocate memory for objects or other data types in heap. So that is what I am doing. Okay, now point to remember is this: inside my stack there is a pointer called P, and in my heap there is an object. My pointer which is in P is pointing to this object which is in heap. Okay, so P is a pointer of type parent class, and the object that I have created in heap is a object of type parent class. Alright, all these are good. So one thing that you should think about when I call this function, okay, then memory is going to be allocated for this pointer P in stack. All right, so this pointer P which is going to be in stack is going to point to a object in heap. Then once I come out of the function, the memory that was allocated for the pointer is going to be deallocated. Is the memory for the object that I create in heap going to be deallocated? Now that is something that you should think about. Pause the video, think about it. Okay, let us compile and run this program, and the output that you see would be a very good indication of what is happening. Okay, so first in this line number 16, I print this before fun. Then I am calling this fun function. So inside this fun function I am creating an object. When I create this object, the constructor is called. Okay, and then I come out of this function. Interesting thing to note is that the destructor is not called. Okay, so I go to line number 18 and I print after fun, and then I exit out of this program. So yeah, the destructor is not called. Why is the destructor not called? Because the object still exists. Yes, there was this pointer called P that was I had created this pointer P in my fun function. This pointer P was pointing inside this fun function. I had created an object in heap. This pointer P was pointing to that object. Now this pointer is removed, but the object still exists. We did not deallocate this memory that we had allocated for this object in the heap. We did not deallocate it. Okay, so the object still exists. There is nothing pointing to that object. Okay, so there is this place in memory, in heap memory, where something exists. This pointer, it is no, this object that we had created inside fun, it exists somewhere in the heap. Okay, but there is no longer, after returning from this function, there is no longer anything pointing to that object. It is a useless waste of space, but the object exists. Alright, so that is something to consider. Okay, why is the destructor not being called? Because the object is not yet destroyed. The object still exists. Yes, there is nothing pointing to that object. We can no longer use that object, but the object exists in memory. The object is there. Okay. Okay. Now let us explicitly delete the object from heap, and we will see whether the destructor is being called. So we have created this object in line number 13. Next, let me just say using the object in line number 14, and then I'm going to delete the object in line number 15. So let us now go ahead and compile and run this program. Okay, so yeah, line number, this line prints before fun into my console. Then I am calling the fun function. Here I am creating this object. When I create this object, the constructor is called, and then I print this using the object, so that is being printed. And when I delete this object from memory, at that point the destructor is called. Okay, fine. Okay, all these are good. Now let us do one thing. Okay, same thing applies in instead of fun function. If I do this in main function, say I had created an object in main, and then I'm doing something in main, and then I delete this object, the same thing is going to happen. When I create this object, the constructor is going to be called. Then this line I am printing using the object, so that is being printed. And then when I delete the object, this destructor is called. Okay, okay, fine. Let us go ahead and now create another class. I'm going to call it child class, and it is going to inherit using this public mode of inheritance from the parent class. Okay, and I have child class constructor, and I am going to simply print constructor of child class. All right, and then I am going to have a destructor as well. And this is going to be destructor of child class. Okay, now let me go ahead and create an object. Okay, over here. Okay, I am going to create an object of parent class first. So let's see what will happen. So let me create this in heap, because I just want to look at the output of constructor. Okay, we will later on delete the object and look at the output of destructor, but right now let us go ahead and create in heap. I will not delete anything, and I will just look what happens, how the constructors are being called. Okay, so parent class object, I am going to create an object of parent class, and let me go ahead and compile. I should not be expecting any error. Okay, I should not be expecting any difference in my output. Okay, because I did not make any change in parent class. So when I create an object of parent class, this constructor of parent class was called. Okay, the object that I had created is never removed from memory, so the destructor was never called. Everything is fine. Now instead of parent class, let me create an object of child class. Okay, now here is something interesting. When I create an object of child class, the constructor of parent class is going to be called first, then the constructor of child class is going to be called. That means if I have inheritance, alright, then the topmost level class, that is at the top of the hierarchy of inheritance, the class that is at the top, that class's constructor is going to be called first, then the class that is below the topmost one is going to be called next, then the next, and the next. This is going to happen until and unless I reach that point where I am creating this object. The class of the object is going to be the last one that is being called. For example, I'm creating an object of child class over here. So the constructor of child class is the one that is going to be called. Okay. So this is the sequence in which the constructors are going to be called. First, the grandparent, if there is a grandparent, then the parent, then the child, then if there is a grandchild, the grandchild, and so on. In this sequence, the constructors are going to be called. Let me demonstrate this by creating one more class. This is going to be a grandchild class, and this is going to inherit from child class. Alright, I am going to need a constructor and destructor in my grandchild class as well, and I have to of course name them grandchild class and grandchild class, because our constructor and destructor should have names similar to the name of the class. Alright, then I need a semicolon, which I forgot the last time. I have this habit of forgetting semicolons. So look at the error message, it will inform you that you have forgotten semicolon, and you can put the semicolon if you have made that mistake. Okay, now I have created a grandchild class. Okay, let me go ahead and compile this program. And let's try to see if I see any change in output. No, there is no change in output. Why is that? Because I have created a object of child class. Okay, so what are the constructor that are going to be called? Parent class and child class, right? So child class is the object that I have created. Had I created an object of grandchild class, then what would happen? First, the parent class constructor will be called, then child class, then grandchild class, right? That makes sense. Let us go ahead and create an object of grandchild class. Okay, now let me compile and run this program. Okay, yeah, hold on, I should write grandchild over here. Let me compile and run. So the constructor of parent class is called first, then the constructor of child class is called, and then the constructor of grandchild class is called. Okay, as expected. So that is what we were talking about, that this is the way in which our constructor will be called. This hierarchy of inheritance, the topmost class constructor will be called first, then the second, then the third, and so on. And you can see that. Okay, now how is the destructor called? So let us delete this object that we had created. Now we are going to see the output of destructor as well. So just to show you some demarcation between constructor and destruction, I am going to draw this line. Okay, let's go ahead and compile this. Alright, so the sequence in which your destructor will be called if there is inheritance is the reverse in which the constructor were called. So parent, child, grandchild, that is the way in which the constructor were called. In case of destructor, first the grandchild will be destroyed, then the child, then the parent, then the grandparent, and so on. It will go in the reverse order in which your constructor were called, right? You can see that over here. Alright, okay, now let me do one thing. Instead of creating this in heap, I am now going to create this in stack, and I am going to compile and run this. Okay, I don't need this. Okay, it will be automatically deleted when returning from main. Okay, so let me go ahead and compile and run this. Okay, so in line number 31, I am creating this object P. This is an object of grandchild class. Therefore, the parent class, child class, and grandchild class constructor are called in that sequence. And then I am doing something in line number 32, my programming logic. And in line number 33, I am returning from main. When I return from main, this object P, which was allocated memory in stack, is deallocated. Right? This memory was given for P. this memory is taken away, right? So when this memory is taken away, when this object is destroyed from memory, at that point of time the destructor are going to be called, and the destructor are called in the reverse order of in which the constructor were called. So first I will destroy the grandchild class, then the child class, and then the parent class. Alright, in the reverse order. So this is what you see on your screen. Alright. Now we will be talking more about inheritance, but not in 3 level of inheritance, but using only 2 levels. Alright. And we will be looking mainly at constructor. So destructor is done. We will not be talking about destructor anymore. So the basic takeaway from destructor is one class will have only one destructor. Unlike constructor, there can be multiple constructor overloaded over each other, okay, with different signature, but destructor will be only one. Like constructor, destructor does not have any return value. Unlike constructor, destructor can never ever take any parameter. Okay, fine. Now I have this child class P that inherits from parent class, and I know, let me remove the destructor. We will not be looking at destructor anymore, so let me remove the destructor as well. Okay, now let us say that for some reason my parent class, okay, needs a parameter. My parent class constructor needs a parameter. Okay, so previously the constructor that I had did not take any parameter. Now I have a constructor that takes a parameter. Okay, so let me print the parameter as well that I receive. So yeah, this is what I have. So previously when I called this child class object, when I created this child class object, right, the parent class constructor was called. So the parent class constructor did not take any parameter previously, and therefore it executed without any problem, without any issue. Now my parent class constructor takes a parameter. There is no constructor that does not take any parameter. Okay, so let's see what happens. Okay, I am getting an error. So if I have a constructor that does not take parameter, okay, and if I execute this, now everything is going to run fine, right? When I create this child class, the parent class constructor that does not take any parameter, that is the one that is going to be called. But say because of some reason, because of my application logic, I need my parent class constructor to take a parameter. So this constructor that I have that does not take any parameter is not allowed, say. So this is the constructor that I have. Now as we have already seen, I am going to get an error. Okay, it says that the error says that parent class, this method parent class expects one argument but 0 were provided. Okay, so one argument, one parameter was expected, but none was given. So what do? We have to explicitly call this constructor. Okay, and we have to pass the parameter that we wanted to pass. Say I am hard coding this integer 5. It is my parent class constructor is expecting an integer, so I am going to call the parent class constructor and I am going to pass a integer. So here I am hard coding this integer 5. Let us go ahead and compile this, and yeah, now it runs nicely. Constructor of parent class is called with this parameter, this argument that I had passed 5. So constructor of parent class is called with 5, and then after running the parent class constructor, next I am running the child class constructor in this sequence. So parent, child, grandchild. In this sequence I am going to go on calling this constructor, right? So yeah, I am passing a parameter to my constructor. Now say my child class takes constructor. Okay, I am hard coding right now, but say my child class takes two constructors, right? So now I have to uh, pass two constructors. Means when I'm creating this object, I have to pass two parameters. So I'm passing 4 and 5. Okay, now say out of this two, okay, I am going to pass one of these parameters over here. Okay, I am receiving two parameters I and j, which has the value 4 and 5 when I'm creating the object. So one of these two parameters I am going to pass to my parent class. So that is what I do. Very simple. Instead of this hard-coded value that I had written, I am going to pass whatever I wanted to pass from this parameter list that I have. So parameter list are I and j. So say I am passing I. Okay. So this is what I do. Let me go ahead and compile. And yeah, constructor of parent class is called with 4. Okay. So I had the value of 4. So I am passing 4 as my first argument. First argument is I. So I am passing I to my parent class constructor, and that is equal to 4. So I am passing 4 over here. So constructor of parent class called with I, which had a value of 4, and that is what is printed over here in my output, right? So this is the problem that we had is now removed. Okay. Now this may also happen. Say I have overloaded with two different this parent class constructor I have overloaded. One takes one parameter, the other takes two parameters. So constructor of called with now I and j. Okay, and what I'm going to do is I'm going to pass I and j over here. So let me write this over here as well. Okay, and I'm going to overload the child class constructor as well. Okay, sorry, this should be I, this should be I. There was no j in here. Fine. Okay, now what is going to happen is I'm creating this object with two parameters, right? I'm passing two arguments. So this constructor of child class, I'm creating an object of child class. So this constructor of child class is going to be called. Okay, and then what this is going to do is it is going to relegate this to the parent class, and the parent class constructor with two arguments is going to be called. Okay, with I and j. So first parent class is going to be called with I and j, means parent class is going to execute with I and j, and then child class constructor is going to execute with I and j, and then we are going to we would have created the object. Okay, so let us go ahead and compile this and see for ourselves. Yes, parent class constructor is called with 4 and 5, constructor of child class called with 4 and 5, right? So everything working as expected. Now instead of sending two parameters, if I send one parameter, then I am going to see that this method is called constructor of child is called with 4, and then this is going to call the parent. So constructor of parent is called with 4. So the order is of course first I am going to print parent, then first I am going to execute parent constructor, then child constructor, right? And that is what is happening. Constructor of parent class is called with 4, and then constructor of child class is called with 4. Okay, now there is this thing. It is not necessary that if you have one uh, parameter in child class, so you have to print one parameter. Means you have to call the parent class constructor with one parameter. You have one parameter over here, you can do one thing. You can print 2 into I, say. So now we are calling the parent class with 2 parameters, and say this child class takes 2 parameter, and instead of calling the parent class constructor with 2 parameter, I can call the constructor of parent with 1 parameter. So that is also not a problem. So let us go ahead and compile this. Yeah, so child class I am calling with only uh, one argument, right? So this is going to be called, and then this is in turn going to call parent class constructor with 2 argument. So I am going to execute this with 2 arguments. So it's 4 and 2 into 4, that is 8. So I'm calling constructor of parent class with 4 and 8. Then this is what I had called. So constructor of child class with only 4. This is going to be printed, right? On the other hand, if I pass 2 arguments over here, then what is going to happen is this is going to be called, and this in turn is going to call the parent class constructor with only one argument, right? So this, so yeah, this is going to be executed first, line number 5 to 6 7, and then this is going to be executed line number 17 to 19. So let us go ahead and check if that happens. So that happens, right? We are calling the constructor of parent class that has only one parameter, line number 5 to 7, and then we are calling the constructor of child class with 2, that takes 2 parameter, line number 17 to 19. Okay, so this is what we do in C++ when we have to call the parent class constructor. Now by default, if you don't specify which constructor of parent class to call, then the constructor without any parameter, that does not take any parameter, is going to be called. And if you don't specify by default which constructor to call, and parent class does not have a constructor that takes no parameter, and it has other constructor, then you are going to have an error. Okay, if there is no constructor at all in parent class, then of course there is not going to be any error. But if there is a constructor that does not take parameter, that takes some parameter, and there is no constructor that does not take any parameter, and in your child class you are not explicitly calling this constructor that does take parameter, then what is going to happen is you are going to have error. We have seen that. Okay, fine. So this is calling parent class constructor from child class. Okay, now say you want to access grandparents constructor, that you cannot do from child class, that you have to do from parent class. So from child class you will call parent class constructor, and from parent class you can call grandparent class constructor, and so on, right? So you have to jump one step at a time. Okay, now in Java there is something called super. Okay, you need not worry about that now, but in Java there is a keyword called super, and if you, that is used to call this constructor of parent class. All right, so this is what we have. Okay, now let us remove all this and let us go back into parent class. I don't need this. Okay, so in my parent class I am going to do this. I am going to have some private member, or let me not make okay, let me keep this private. Okay, this is a integer pointer. Okay, now in my constructor what I am going to do, constructor is going to take one value. Okay, and then it is going to this ptr, it will allocate memory for ptr in heap, interesting. Then it is going to set the value of ptr which is in heap to this I that I have passed to the constructor, right? And in the destructor I am going to remove this ptr from my memory. All right, so apart from that I am going to have two more, one setter and one getter. So one set p, that is just set, that is going to take an integer say p, and it is going to set the value of ptr is equal to p. Okay, and there is going to be another getter that is simply, so this is going to be an int getter that will simply return the value of p. Okay, fine. Now when I create this object I cannot pass two parameters, I have to pass only one parameter. Okay, now let me do one thing. I am passing 4 to this object, right? So let me print the value of p dot get, so that will return the value of this this pointer is pointing to some place in heap memory, and there is some value stored at that place in heap memory. So this get is going to return that value. Sorry, it is not 0, it is ptr, the value of at that place. Okay, sorry about that. So get is going to return the value of whatever this ptr is pointing to. All right, and then I will do one more thing. Let me write a n line in here. Then p dot set I am going to do. Okay, here I am going to set p to 5. Okay, and then I am going to print the value again, p dot get and n line. All right, so these are the things that I do. Let me go ahead, compile and run this program. Okay, so first I am printing, I am creating this object. So when I am creating this object, what is happening, this constructor will be called, and inside this constructor I am allocating memory for this integer in my heap memory, and at that memory which I allocated in heap, I am putting this value that I pass to this constructor. In our case I am passing 4, right? So this pointer is pointing to some location in heap where I have space for a integer, and at that place I am storing this value 4. Okay, then I call this get method. When I call this get method, that memory's value is being returned. So this pointer is pointing to some location in heap. I had stored 4, the value 4 in that location. This get is returning that value 4. Okay, so I'm printing 4 into my console. Then I call this set method, which updates that location that pointer is pointing to whatever is being passed. So I'm passing 5. So previously there was 4, now it is being updated to 5. And then I call get again. So when I call get again, once again that location value which was 4 previously and now it is 5, that is being returned. So I get 5, right? So I have updated it to 5 and I'm getting 5. Fine. Now what will happen once this program ends, then the destructor will be called. I did not create destructor. This is another constructor that I had created. Sorry, this is the destructor that is being called. Okay, and this memory in heap that was allocated, in which I stored this 4 or 5 that was pointed to by this pointer, that memory is deallocated. Alright, and this object is destroyed, and we come out of the main program, we exit the program, we are done running our program, right? Okay, now I am going to do something else. I am going to create a parent class object called q. Okay, up to this point we were working with this parent class object called P. I am going to create a parent class object called Q, and I am going to assign that to P. So I am copying P to Q. Okay, that makes sense. Okay, now let me print out the value of Q. Okay, and let me compile and run this program. Okay, it is printing 5 again, and that should okay, sorry, so something happened. Okay, we will handle this. Okay, let us not remove this from memory in destructor. No reason. There is a reason that I will tell later. Right now there is no reason. Okay, I am copying this Q to P, and I am going to print P. So let us do that. Okay, so P initially had a value of 4 when I called this constructor. So I printed that value of 4, and I get 4 value of P, that is 4. Then I update P to 5, and then I print this P dot get. Okay, I print P, so I get 5, and then I am copying P to Q. Okay, so I am creating another object Q, and I am saying P and Q, both of them, so whatever is in P, copy that to Q. So that is something that I am doing. Okay, and value of Q I am printing. So I had copied P to Q, so when I print Q, I am getting 5. So this is fine. Okay, there is no problem at this point. Okay, now let me do one more thing. Let me create a public integer. Okay, or let me create private. I'm calling it stack int. Okay, I'm creating another integer. This is not in heap, this is in int, and I'm going to simply set it to stack int is going to be 2 into I. Okay, that's not going to pass another parameter. You can do that as well, not a problem. And I'm going to create 2 more function. One is to set stack int to some integer P, and that is simply going to set stack int to P, and another function that returns the value of stack int. This does not take any parameter, and it simply returns stack int. Alright, so here I was getting the value of this pointer, whatever this pointer was pointing to. Now let us work with this other thing, right? This stack int. So I will write asint, then set asint, then get asint again, and here also I am going to get asint. Okay, let us go ahead and compile this. Okay, once again, so what is the problem? Yeah, I am setting I'm calling this object, when I'm creating this object, I'm passing 4. So this asint is set to 8, 2 into 4. Then I am setting asint to 5, and then this is what is happening. First it was 8, then it became 5, and then I'm copying this p to q, and then I'm printing the value of asint through q, and so I'm getting 5. Okay, this is not a problem. Now let us do a few more things. I will update the value of p asint to 10. It was 5. Okay, and I am going to print the value of q asint. I did not change q asint. Okay, I am changing p asint. Why is there an error? Okay, this is not get, this is set. I am setting asint to 10. Okay, stack into 10, and I'm going to print see, this is what I'm doing. There are two objects, p and q. Just before this, what I had done, I had copied p to q. Now q is a different object, p is a different object. Okay, now p's asint I'm going to change to 10. When I copied, it was 5. Okay, now q should have the value of asint 5, p should have the value of asint 10, right? That makes sense. Here I am copying p to q, then I am printing the value of asint in q, then I am setting the value of asint in p to 10. Again I am printing the value of asint in q. Okay, now remember, between in this line I am not making any change to asint. Okay, so observe that. Let us go ahead and compile and run this. Okay, so the value of q did not change. Okay, this is expected, right? This is expected. Why? Because I have made changes in value of p. So if I print the value of asint in p, I would see that asint in p is now 10, but asint in q is now 5. Okay, because I did not when I copied p to q, the value of p asint in p was 5, so that was copied to q, and then I changed p. I did not change q, so p's value has now changed to 10, but q's value is still 5. Okay, nothing confusing over here, right? Okay, I'm going to make one small change. Instead of asint, which is in stack of p and q, so p's asint is in stack, as well as q's asint is in stack. These two objects, both of them are in stack inside different objects. Both the objects are allocated memory in stack. These are local variables, right? Now I have removed all this asint. I am now working with this ptr. Okay, there is this ptr, and let me remove asint. We have done working with asint. Okay, if I copy asint at some point of time, then I will have two copies of asint. If I make changes to asint at one place, the other place is not going to be affected. So you have seen that I can change one, the other will stay the same. I can change the other, the previous will stay the same. Everything is good. Okay, now we are back to working with this ptr. Okay, ptr is what? Ptr is a pointer that is pointing to some memory location in heap. Okay, now let us go ahead, compile and run this. Okay, now we have a problem. Here we had set the value of this ptr to 4. Okay, then we print the value of ptr, we get 4, that is fine. Then we set value of ptr to 5, we print that, we get 5, that is also fine. Then we copy p to q. Okay, after copying we print the value of q. Previously we were printing the value of p, now we were printing from q, and we get 5. That is fine. Up to this point we had just copied, the value was 5, we copied, so now we have the value 5. Okay, then what do I do? Q has the value 5, p has the value 5. In location, in line number 30, I am changing the value of p to 10. Q I am not touching. Okay, but in line number 31, when I am printing the value of q, I see that that has changed as well. Okay, I did not touch q, observe that, but this has changed. As well as in line number 32, I had explicitly changed p, so when I print the value of p, it has changed. That is not a problem. Okay, but in line number 31, the value of q has changed, although I had changed the value of p. So what is happening? This is happening. This is a pointer, right? PTR is a pointer that is pointing to some location. When I copy that, okay, unlike previously when I had this stack integer async, when I had that, these were two different objects in stack. Okay, I had one object in stack, I copied it, it was another object in stack. Okay, there were two different versions of async. One was inside p, one was inside q. Now also we have two different pointers, right? One is inside p and one is inside q, but both these pointers are pointing to the same location in heap. Okay, so if I use p's pointer to change the value of that location in heap, and I try to access through q's pointer, I am still accessing the same location, right? We have two different pointers, that is fine. There are two different pointers, but both of them are pointing to the same location in heap. So that's a problem. Okay, now if I change the value of p, the value that I am accessing through q, that is also going to change. If I change the value of q, the value that I am trying to access through p, that is going to change. So both these things are pointing to the same location in heap. Okay, so if I make change through one and I try to access through the other, I am going to see that the other has changed as well. This is some behavior that I don't want. Once I have copied one object to other, I want both of them to be independent. Okay, changing one should not affect the other. Fine. So what to do? And right now I am showing in integer, but then imagine that you have two stack. At one point of time you have copied one stack to the other, and then you are making some changes in one stack, and automatically you were expecting that there would be two stacks, but you are means pushing and copying something in one stack. The other which you expected not to change is also changing, right? So this is a problem. Now please do understand that we are right now trying to work with integer, and integer I am showing just because it is easy, but then you can very easily imagine that instead of integer there can be array, linked list, anything, any other structure. No matter what if it is, this pointer is pointing to something, whatever be it in heap, this pointer points to that location in heap. If I copy that, this new pointer in my copied object is also going to point to that same thing. Okay, so no matter it's a integer or float or some complex struct or whatever, okay, we are pointing to the same location. So that's a problem. I hope you understand the problem very well. All right, so what to do? So once you have understood the problem, now it's time to resolve the problem. I am going to create a new type of constructor called copy constructor. Okay, once again constructor is going to have the same name, but this is going to take a object of the same class. And let me keep it constant because I'm not going to change that whatever I'm going to copy from. So I'm going to copy from one to my to this new, right? But I don't want to change whatever I'm copying from. I'm going to call this X, and what I'm going to do is this PTR, I'm going to create a new location in heap, and then the value in this PTR is going to be X dot get. Hold on. Okay, do one thing. Let me not use this get. I'm directly going to call PTR. Okay, and the value of PTR. I'm going to get the value of PTR and I'm going to put it over here. Okay, what is this going to do? Okay, what is the error? Why is there an error? Okay, there is no error. Okay, fine. Okay, this is one problem with Visual Studio. Sometimes you don't have error, but they still show this red line. Anyway, this is a copy constructor. Okay, what does this constructor do? This copy constructor overloads this assignment operator, this equal operator. Equal is not equality operator in C++, right? Double equal is equality operator. Equal is assignment operator. So I am assigning Q equal to P. So I am copying Q to P. When I am assigning, when I have this equal symbol, when I am trying to create this Q object using this equal symbol, that means I am copying from someone. Okay, then instead of this normal constructor, this one, this will be called. Okay, now you might have guessed by now that there is a default copy constructor. Okay, therefore we were able to assign P to Q without anything. So the default copy constructor did what? It simply copied everything, right? Including this PTR. This PTR had this value that was this PTR was pointing to some location in memory. Once we copied, we were copying pointing to the same location in memory because the location was also copied. Okay, now in this copy constructor that we have created, what we are doing is this: we are creating a new location in memory. Okay, we in this line we are creating a new location in memory, and then into that location we are copying from P, right? So when we are creating Q, this, so this constructor will be called. So there are two objects over here, P and Q. Q is the caller. Q is going to call the copy constructor. Okay, So this is essentially going to be q dot this copy constructor, and it is going to pass p. Alright, this is how it is going to be called, and this is the copy function that I have written. Okay, here inside what I have done, I have created a new location in memory, and into that new location from this p was passed, right, into this as an argument, as a parameter. So I am going to copy the ptr from p was passed. I am going to copy from p, and I am going to put it in the location that q is pointing to, the location in heap that q is pointing to. Okay, now think about what has happened. P was an object that had this pointer that was pointing to one location in memory. Now when I copy, okay, this new copy constructor is called. What is copy constructor going to do? It is going to have a pointer, like P had a pointer. Copy constructor, this q is also going to have a pointer, but this pointer inside this copy constructor, I am going to allocate a new address in a new space in heap memory that this q's pointer is going to point to, right? And then what I will do, I will copy the value that p's pointer is pointing to. I will copy that and I will put that in the place where q's pointer is pointing to. Now previously what was happening, both p and q were pointing to the same location in memory. Now they are pointing at different location in memory, right? Therefore when I run this same program again, okay, what is happening in this program? Here I am creating an object p with this value 4. I am printing the value 4. I am now updating the value to 5. I am printing the value 5. Now I am copying, right, this p to q. I had this p that right now has a value of 5. Okay, this value 5 is in some location in memory that this p has a pointer. That pointer is pointing to that location in memory. When I am copying, what is happening? Q is calling this method. And what is this method doing? This method creates another object is created, and when this method is called, this pointer in this new object, this q object, this is now allocated a new location in memory. In line number 13, this pointer is pointing to another location in memory. Okay, another location in heap memory is created, and this pointer is pointing to that. And in line number 14, what we are doing is we are copying this p was pointing to some location in memory. We are getting the value from there, and then q is pointing to some location in memory. We are copying this value that p was pointing to this location that q is pointing to. All right. If you have confusion regarding this, then experiment on your own. Okay, run program, do things on your own. A bit of your confusion should go away, but then in our theory class we will be addressing all of this with pen and paper, and I hope at that point of time all your confusion will go away. Okay, so that is what is happening. P is copied to Q, but this pointer are now pointing at two different locations. So P and Q, both of them are pointing at two different locations. Now here I am printing the value of Q. Yes, both of them are pointing at two different locations, but when we did this copy, I copied this value that P had. P's pointer had the value 5. I set it here in line number 30, right? We set that to 5. So that was copied to Q. So when I print Q.get, I am getting 5, right? We copied that. Then I am setting P to 10. Okay. And now I am going to print Q again. So Q is pointing to some other location that should not be affected, and P is pointing at some other location that has now been updated, right? And this is what I am going to get. So P was 4, we updated it to 5. Now after copying, Q has a value of 5. Okay, and then we changed the value of P. after changing the value of p, q still has a value of 5 and p has a value of 10. Now remember what was happening in stack int when we changed, means what was happening without copy constructor. When we changed the value of p, the value of q was also changing, because we were changing in the same location. P and q were both pointing at the same location, but now because they are pointing at two different locations, when I change one, the other does not get affected, right? So this is copy constructor. Now copy constructor, this kind of constructor is run when assignment of object is done. When one object, we are creating this object q, but we are not creating this object like we create object like we had created in line number 28, right? Here we are creating this object by copying from another object. We are, yeah, that is what we are doing, copying from another object. So this copy constructor is run when we copy from another object, when we have this assignment operation. Okay, so this is what it is. Now if you remember previously when I had this delete, okay, without this copy constructor, let me remove this copy constructor and execute this program. We had some stack error. Okay, we had this error that I am trying to free up 2 times from memory. Okay, so why is this happening? Because when I am trying to return from main, okay, at that time I am trying to remove both p and q. So when I remove p, say I am removing p first, then say I am removing q. So when I remove p, then the destructor of p will be called, so this one, and the destructor of p will do what? This p and q both had this pointer that was pointing to the same location, remember that. So when I call the destructor of p, in that I delete this memory that was allocated in heap, that this pointer, both p's pointer and q's pointer were pointing to. When the destructor of p is called, that location in heap is deallocated. Okay, so there was this memory in heap that was allocated, that this pointer was pointing to, this p's pointer was pointing to, and that is no more there, that is deallocated. Next, what do I do? The destructor of q is called. Now destructor of q, again I am trying to deallocate the memory at the same location. Okay, now p's pointer and q's pointer are pointing at the same location. I have already freed up this memory. When the destructor of p was called, I freed up that memory in heap. Now when the destructor of q is called, I am once again trying to free up the same place in memory. Okay, so I get an error. Now if I have a copy constructor, we have 2 different places in memory. When the destructor of p will be called, this pointer of p was pointing to one location in memory, that would be free up. When destructor of q is called, there is this other location in heap memory that this q's pointer is pointing to, that would be freed up. Okay, and this error that we had will no longer be there. So let's go ahead, compile, run, and we no longer have this error. Okay, fine. So this is all about copy constructor. So yeah, this is all about constructor and destructor that you should know at this point. Apart from this, there are other nitty-gritties regarding constructor and destructor. We will talk about a few of them in our theory class. For example, some rules are there, whether those, what are inherited, what is not inherited, what can be inherited, okay, and then what can be virtual, what cannot be virtual. So all these things we will talk about in the theory class. So in this class we have seen what is constructor. We had seen that before. We saw that constructor can be overloaded. We had seen that before as well. We saw what is destructor, so that was something new. We saw that destructor cannot be overloaded. Both constructor and destructor do not have a return type. Constructor can take parameters, destructor cannot take parameters. Now we saw what happens in inheritance. In inheritance, from the top of the inheritance chain, from parent will be called first, then child, then grandchild, and so on. Constructor, that is the sequence in which constructor are called. The destructor we have seen is called in the opposite sequence. So grandchild first, then parent, then grandchild first, then child, then parent, and so on. Right? So we have seen all this. Then we have seen how to call the constructor of parent explicitly. Okay, so if there is no, we do not do that, then automatically the constructor of parent that does not take any parameter, that is going to be called, if we do not mention which constructor to call. Once we create an object of child class, which constructor of the parent class should be called. If we do not mention anything, then automatically the constructor that does not take any parameter, that is going to be called. But if we do not have such a constructor that does not take any parameter, we are going to get an error. In that case, what to do? How do you explicitly call a constructor that takes parameter? How do you pass parameter from the child's constructor to the parent's constructor? Okay, we saw that as well. And then we saw what will happen if we copy one object to another object. Okay, say we saw that with one local variable which is there in stack. Okay, so if stack will be copied, so there will be no problem. But then if memory is allocated in heap, okay, instead of stack, if we have pointer pointing to same location, some location in heap, then once we copy, this copied object will also be pointing at the same location in heap. Okay, so if I update one, the other object's value will also get updated. So what to do in such a case and how to handle such kind of copying? So we saw something called copy constructor that can allow us to handle such situation. So that was the content for today's video. I hope you understood everything that we talked about in this video. If not, you can of course reach out to me through WhatsApp, mail, or by writing your doubts in the comment section below. Thank you for watching this video and see you in the next video.